When you have a multi-part plaster mold, you have a few options for aligning the plaster halves. This is true for vessels as well as handles or other forms as well. So the simplest is no alignment features at all besides the mold itself. That's what I did recently in this two-part mold to make this form here. In particular, this face here is just flat, as is this one, and to use this mold, you just stack the pieces together. These can be shifted around, which would result in an offset in the pot, which is not what you want, most likely. However, since I 3D print my molds and I use the outer molds as well instead of cottle boards, that means this surface on the outside is actually very good. And so it's pretty easy to align these pieces so that the inside seam is also good. For my handles, I've done a slightly different approach. I have these small mold keys here, and these are formed from the 3D print. There's a small recess here and a small bump here. So when the plaster is poured against that and released, we wind up with the opposite features there. These are relatively shallow because I wanted the bottom plate to be relatively shallow as well. Basically, I'm limited by the thickness of this plate. There's also a tolerance built into this, and that's because people's 3D printers aren't perfect, and depending on your printer, you'll need different resolutions. So these actually are really just there for rough alignment. So you can put them all together, and it'll slide around a little bit depending upon the resolution of your printer and how good it is. You can also make notches in the traditional way. So imagine this is our form that we want to make a copy of. You would then put some cottle boards around the outside and you would pour basically up until the parting line. So you'd pour this piece here as one pour. You could then take a tool and dig in recesses here. You'd put mold soap on this face so the plaster doesn't stick to itself. In particular, the plaster crystals will want to grow and connect to each other. The mold soap prevents that. But when there are recesses here, when you then pour the second pour, the plaster will flow down into that spot, and that'll create the mold keys. Also, this face is likely less than perfect, so there probably are small imperfections in it. All of those small little imperfections also create registrations for the two pieces. You'd then demold it. You'd have the recesses here, the protrusions here, or vice versa, so that when you put it back together, it would align. And the last option are these here. These are little plastic pieces, and the idea is that they get embedded in the plaster somehow, and there winds up being a corresponding hole in the opposite face, and that's what's used for alignment. I've had multi-part molds on my brain for a little while, in particular making this one as a two-part mold. And recently, Tony from Digital Fire posted about some 3D printed notches that he's made. In this video, I want to go ahead and dig into those notches and see how they work. So I've seen these before. Here are the notches that are for sale. I'm guessing these are injection molded, but I've seen basically no information on how these are used. I've seen them inside of molds, which I'll show you in a second, but there's basically no instructions that come with this. Tells you how much they cost. It says it's great for the serious mold maker, and it's sold in two parts. But how do you actually use this? And then here's an example of them in place or something very similar. You can see this yellow piece here that's been embedded in the plaster as the positive, and then there's an associated piece here on the other side, which is the negative, so they'll slot together and slide apart. This is obviously for a handle mold. And here's another example. This is actually a three-part mold, but you can see, again, here's the positive pieces there. They have a traditional notch down here that's made out of plaster for some reason. I'm not too sure why. And here you can see the mating faces. So here are the male pieces on this one side, the female pieces on the other. And this bottom piece here, so this is a three-part mold. I'm sure there are female pieces in the bottom of the walls as well. But how do you actually put these into the plaster? That was one of the questions I had. And here is the Digital Fire page talking about mold notches, the ones that Tony's designed. He's actually gone through several different iterations. So his first one here says that they're standard self-interlocking mold notches. I think this design is meant to mimic the ones I just showed that you can buy pre-made. These are 3D printable. I think the way these are intended to work is that the top part here fits into the bottom part here, so it's symmetrical, but I'm not exactly sure. He then revised this and made these 4 pieces here. He has the spacer, the notch, the embed, and the clip. However, I wasn't quite sure how all of these fit together. He changed the dimensions, so this one's 13.5 millimeters. The old one was 9.8. He talks about pouring on a flat surface and that the traditional notches don't work that way. And I think what he's talking about here is something similar to what I do with the shape cast molds, where there is this bottom piece, the inner mold, and the outer molds. And the plaster is basically poured this way, upside down for this piece. And that's so you have this flat face here. And so if the notches were placed there, somehow they'd be sticking out, and that doesn't work. The other advantage, he says, about being able to pour flat is that you can sand the surfaces. Basically, you can lap them together. A few years ago, I was talking to a bunch of slip casting artists for some research, and one of the artists actually cut his molds and then lapped them flat. And that's something I've always had in mind. If this surface for some reason wasn't perfectly flat, and one reason for that is 3D prints don't always stay flat, especially flat pieces, you could sand this just slightly to improve the mating faces here. Versus with handle molds, with these features in it, you can't do that. And I have noticed on some of my prints that they aren't perfectly coplanar. There winds up being a little bit of flash. It has not been a problem in practice. But if you really want to dial in the molds, being able to post-process this surface so they really do fit together could be desirable. Then he has an example here of making a handle. I'll talk about this in a bit more detail. And then recently, which kind of sent me down this rabbit hole, is that he's done a new version. So I think it's very similar to the previous one. He actually has some technical drawings here, which we'll talk about. His 3D models, which you can actually buy from his website, have different parameters. So there's the inside dimension, outside dimension, and slack. The slack is basically a tolerance for the 3D prints. Since 3D printers aren't perfect, you might need to increase or decrease the tolerance based on your specific printer, which is related to the tolerance I added to the handle molds. So it basically says print all these out, adjust the slack parameter, the tolerance parameter, and print again until they fit well. It says you need them in multiples of 7. I'm not too sure about the 7. I think this is actually a bug. So you need 2 notches here, 2 embeds, 2 clips, and 1 spacer, since that's the quantity you'll be consuming them in. And then Tony offers for sale either the 3D models where you can go and adjust all the parameters, or ones that already have all that geometry baked in. However, in the little bit of experimenting I've done, I think you probably want the 3D models and be able to adjust these in CAD to really tune it to your printer. So here is his latest version. He has both the 3D rendering as well as some dimensions. I used this and modeled up something very similar. I don't think it's exactly the same, but it's pretty close. So here's the top part, what he calls the notch. Next is the spacer. I'm not too sure exactly what that's for. The embed sitting here. I'm guessing this is the part that's embedded in the plaster. And the clip. What's this for? So I played around with these a little bit once they were physical as opposed to just numbers on the page. And so the clip here fits into the embed and it will slide in and out. The spacer also fits into the embed, and as does the notch. So what exactly do these pieces do? So this one here, the notch is the male piece. This is what it's meant to protrude from the face of the plaster. It's meant to stick out of the plaster, and so somehow it sinks down in. There's the spacer, which to me wasn't obvious what it actually did to start with. The embed, given its name, I think this is actually embedded in the plaster. And we have the clip. So if we go over to his handle example, so this here is the embed, and it's sticking up into the recess of the handle. I think this here is the clip. It's sticking through the bottom. And the idea is that the embed then can go over the clip and fit together, and that will let it come apart when you're demolding it. This will wind up stuck in the plaster, and this is just used for registration and alignment. Here he has the notch sticking out of the plaster. So once it's demolded, you have an embed here and an embed here. And what he's done is he's taken the notch and pressed it in, just like that. And here he also has an embed. However, this doesn't fit this way, it's too big. And that's what the spacer is for. The spacer slides into the embed. So that becomes the female piece, of which the notch then fits into, just like that. And that's what he's showing here. And he's experimented some different sizes. I think these are designed to match the commercial ones, although I haven't quite checked that. So how this is designed to work then is that the male part of the notch fits into the spacer, and this acts as the female. The embed then is what's embedded in the plaster, and both of these halves wind up being in the plaster like that. And normally they're fully seated. I don't want to put them all the way down so I can pull them back out. But it then goes something like this together, and of course that winds up being flush. And then the clip is basically just a tool for making the plaster molds. So he's made the embeds the same to work both with the male and female sides. By making the notch in particular removable, that means the surface of the plaster winds up flush with the surface of the embed, which means you could be sanded if you want. And the clip he's using for positioning of the embed. So if we move over to something I'm a little bit more familiar with, instead of this bump here, we wind up with the notch sticking out. But the way that's actually made is there winds up being a hole in the 3D print that the clip winds up poking through. We then put the embed on, so that is in that spot. There's another hole here. The clip goes through. The next embed goes on. We then pour the plaster, just like that. And when we wind up demolding it, the clips will come off with the bottom plate. These are now embedded in the surface of the plaster, like that, and these locations. And we can then insert the spacer or the notch accordingly so we can get male and female parts. And of course we have two halves, so we need one half of the set for the male, one half of the set for the female, times as many notches as we want. So for this mold I would need 2. So I think his usage of 7 there on that webpage is wrong. I think you actually only need 6. You need 2 clips, 2 embeds, 1 spacer, the female, and 1 notch, the male. And as I mentioned, in Tony's version that you can buy the CAD models for, he has these 3 different parameters. One is the outside diameter. This is the outside of the bottom of the notch, or correspondingly, it's the inside diameter of the embed here. And then the inside diameter, which is the inside diameter of the spacer, which is also the outside diameter of the mold notch, like that. And so those can fit together, be pressed all the way down. And then those wind up being inside of the embeds. So here we have that alignment, winds up being perfectly flush. So I talked about how I would use this for the handle mold. Basically, I need to put holes that are this size into the bottom plate here. The same would be true for the shape cast molds for vessels. Basically, we'd need holes. I could decide how many notches I want, 3 or 4. I'd make holes that are big enough for the clips. These would then protrude through. They would poke through the bottom and be sticking up just a little bit. So I could then put the embeds on. We then continue to assemble the mold, put the inner mold on, put the outer mold on, pour the plaster, demold it. So now we have plaster like that. And when we flip it over, we would have the surface of the clip just poking through. It'd be flush like that, so we could pull those out. That would then let us demold the ring. We would then have the embed sunk down into this face of the plaster. Just like that. And of course we pull the inner mold out. We can do the same for the other half. We'd want to make sure the holes are exactly aligned. And then we can decide, do we want the top or the bottom to be male or female? And for instance, each of these would get a notch, each of these would get a spacer, and that would let us push the mold together and then pull it back apart. And again, since these are sunk down into the face of the plaster, if this were warped just a little bit, we could sand it basically just a tad, and because this is insertable, we could then put that in afterwards. So I talked about the outside diameter and the inside diameter, and the last thing is what he calls the slack, or this is the tolerance. And I printed a bunch of different iterations. So the first time I modeled it up, I actually forgot the tolerance in there. And so these pieces here are actually a press fit. So if I take the notch and the spacer and I push it together, it will fit together. If I push it all the way, it's basically impossible to pull apart. They basically are an interference fit because there's zero gap between the pieces. So I caught that bug as soon as I pushed them together and had a hard time getting them apart. I then went and looked at the drawings again. If you look very closely, you can see where he's added this extra slack parameter. He has 0.02 in this model. So basically these two pieces here, and they are very loose. I think this would wobble around quite a bit. So I shrunk it down. I went down to 0.1 millimeters, and these are still a pretty loose fit. And then I shrunk it to 0.05. And these are fitting together pretty tight. Maybe I need to bump it up just a little bit. So I think between 0.05 and 0.1 is probably the right size. And I think this does vary a lot based upon your printer, your settings, everything else. I printed these on my Bamboo P1P on the fine settings, and so that's what I got. I think this is one of the tricky parts for using these. For instance, if I think about embedding it in the shape cast, you would need to do these test prints just like I did to figure out exactly what size you want. However, that's just the raw parts. Once they're embedded in the plaster, do I actually want the larger tolerance? I'm not sure. And is it the same for the vessels as well as the handles? Also an open question. Overall, this was a useful exploration. I now know what these 4 parts do and how they work, how they get assembled into the 3D prints, and then the 3D print is demolded, and then how the pieces are inserted into the plaster and how the plaster is used. In the next video, I think I'm gonna go ahead and try this out and see how it works in practice. Do I like these better than using no mold keys at all? Or are they better than the ones that I have built into the handles right now? The only real way to know is to try. If you have any questions or comments, let me know. Thanks.